Now that we've looked at the elementary charge and different ways that charge can be conserved when charge is transferred, we want to take a look at the different ways that objects are charged. Now there's a few different ways that we're going to look at specifically in this class. The first one being charging objects by friction. So when two objects are rubbed together, there's going to be some sort of charge transfer there. We're going to take a look at charging by conduction and charging by induction. And we're going to talk about each one of these three methods in turn. So let's first talk about how we charge by friction. First of all, know this. Anytime two materials rub together, there's going to be some sort of charge that's transferred from one material to another material. It has to be two different materials for this really to be charged by friction. Let me try to explain why charge is transferred from one object to another object during this. So since the two materials are going to be made up of different sorts of atoms, every atom is going to hold on to its outer shell electrons with a different amount of strength. The stronger that the objects holding on to their electrons, the less likely they are to give it up. So when the two objects are rubbed together, there's going to be transfer of electrons, and the material that's holding on to them stronger will transfer their electrons less than the one that's holding on weaker. So there'll be some transfer based on this. You oftentimes see this. This is the whole idea of why we put dryer sheets in our dryers to keep from static cling happening. If you walk across the carpet, you might get a shock when you touch a handle. All those things have to do with the fact that two materials are rubbing against each other a little bit different. There's a shock. You also sometimes find this with like fleece blankets or different sorts of bedding material that might be rubbing on like your pajamas or something like that. They may rub against it. There might be some charge, maybe some static cling. Maybe you might see some shocks in those scenarios. So whenever you have materials that are rubbed against each other, they're slightly different materials. There will be some transfer of charge between the two, and that is referred to as charging by friction. The second method we're going to look at of charging is called charging by conduction. And charging by conduction is the charge that happens when materials are brought in contact with each other, and excess charge is allowed to go from one material to the next material. And this is how it goes. So if you're looking at this, you can see the video or the different materials here. You have on the image to the right, you have a rubber rod that has a whole bunch of negative charges on there. And you can see that's represented by all the negative signs on the rubber rod. That means that it's negatively charged. To the right of the rubber rod, you see a conducting sphere that has negative and positive charges on there. We're just showing the sphere as being neutral because it has the same amount of positives and negative charges shown. In general speaking, that's how we represent whether objects are negative or positive, just by the imbalance of charge. This is qualitative instead of quantitative. You don't want to read into that to say how much charge is there. You just want to see that one object is more charged than the other object. So here's what happens. That negatively charged rubber rod is now brought in contact with the sphere itself. When it's brought in contact with the sphere itself, some of the charge from the rod is going to be moved onto the sphere itself. Now, after the contact is made, you'll notice that there's less negative charge on this rubber rod because some of that charge that was on the rod is now moved to the sphere. But now we're just representing on the sphere just negatively charged particles, showing that the rod and the sphere itself is negatively charged. So by contact, through physical touching, charge is moved from one object to the other object. That is referred to as charging by conduction. Whenever you charge by conduction, the charge transferred is always going to be represented as the net change. So there's a negative rod. That means we're transferring or conducting negative charge to the sphere. The last type of charging we're going to look at is charging by induction. We're going to follow the diagram here on the page, and you can see it on the right. And we're going to start at the top left where you're looking at just a neutral sphere. So this would be a metal sphere. Now, by charging by induction, we introduce to the neutrally charged metal sphere a negatively charged rod, right? Now this negatively charged, and this would be the image to the top right, you can see you have this negatively charged rod. And what happens is that because electrons are free to move on the sphere, all the electrons that are free to move in that sphere, they all go to the right-hand side of the sphere because they're repelled by the electrons in the rod. That repulsion is trying to move the charge. It's called polarization. We'll talk about that in a moment. Since we have this effect, what happens is that the electrons on the sphere are redistributed, just trying to get away from that negatively charged rod. Moving to the third image, this would be the middle left. We do something called grounding, meaning that we attach the sphere to the Earth, allowing the Earth has a great reservoir of charge. It can take electrons or give electrons whenever there's a need. And so when we ground the sphere, because the negatively charged rod is repelling the electrons in the sphere, the electrons will actually physically leave the sphere itself, leaving that sphere negatively charged. We remove the ground. And since we've pushed electrons off the sphere, that means that sphere has lost negative charge. Once we remove the negatively charged part of the rod in the first place, because we've pushed charge off of this, we find that the sphere itself is actually just positively charged. The process of charging by induction is industrially how we come up with charge. So when you talk about power plants, Niagara Falls, RG&E, all these different ways that we develop charge here in our environment, industrially, I mean on a large scale society sense, we do this by charging by induction. So this is very important for the production of electrical power. The last thing I want to talk about in charging is I want to talk about this process of polarization, which you saw in 2 of the 3 examples. You saw it in conduction, you saw it in induction, and I want to talk about what it means to polarize. You might be familiar with polar as in like the polar caps or the North Pole and the South Pole, or polar molecules from chemistry. What it means to be polar is that geographically 2 different opposite centers move away from each other. Whenever you have a charged particle and you induce polarization, it means that you've redistributed the charges along a material, one on positive on one side, one on negative on the other side, and anything that can become polarized allows the material to separate its charge, the positive and negatives, away from each other. This always happens, and polarization always occurs in the presence of charged matter. So if you bring a negatively charged bit of matter near some other matter, it'll repel all the electrons as much as humanly possible away from that negatively charged, leaving a positive center there and a negative center somewhere else. The one interesting thing about polarization is that when objects become polarized, a neutral object will generally always be attracted to a charged particle because of this polarization, because you can redistribute the charge, meaning that once you push charge away from the presence of the charged particle, it leaves the other charge there. Polarized objects are attracted to matter. So when you answer questions about attraction, opposite charges always attract, but also neutral matter is also attracted to charged particles. So we have neutral material attracted to charged particles, either positive or negative. We have oppositely charged particles attracted to matter. But when you talk about repulsion, only similarly charged materials will be repelled. So neutral matter will always be attracted to charge, but it'll never be repelled by charge itself. When we talk about the realignment of charge, that is the term of polarization.